I'll kick us off. The ROS Medical Community, if this is your first meeting, this was started by Tom Amlick and I, because we care about bringing medical devices to sooner. And we, of course, see the potential for ROS to help with that for various reasons. Tom works with ROS at Medicurity. I used to be on the ROS2 core dev team myself. If you've seen the ROSCon keynote that I gave a few months ago, then you'll know that there are lots of different ways that you can leverage ROS in medical devices. Not all medical robots are surgical robots, and the one that I'm helping to bring to market, I've actually chosen to leave ROS kind of as is for our work, because we are lucky enough to have like a very safe worst case being an imaging robot. But today we'll be exploring the question of like, what if you're not working on an imaging robot? I've invited, well, Nathan as a representative from PickNik, who've been involved in surgical robotics, where you have a different relationship with ROS and safety when you're working in surgical robots, and I'm very curious to hear about that. But specifically, we have the CTO of PickNik with us today, Nathan Brooks, who, in addition to leading like the robotics development for PickNik and their different customers, Nathan has experience working at NASA. So that background of like having used ROS, having not used ROS, I think brings a really interesting perspective. And from what I hear, PickNik is keen to change perhaps the experience that Nathan has had of like those industries being medical and space, not historically leveraging ROS heaps. So I'll throw to Nathan for like mostly an autonomous session. I will highlight that like we're all here together. It is a very unique experience to be able to network even if we're here to listen. So really use the chat while Nathan is speaking, because we won't have heaps of networking opportunity at the end. There's of course the mailing list that you can join, and we have a Slack channel as well for keeping those connections going. So be as chatty as you want. Otherwise, let's all turn our attention to our speaker, Nathan.
Great. Thank you for getting this organized and for the intro. Yes, that's great. This is meeting more often and, once a year at ROSCon and informally through ROS Discourse. All right. So yes, my talk today, I'll give a brief outline. I will spend a little bit of time talking about, PickNik's history and what we're doing most recently, what we've been up to. And I also thought this is in prep for this talk. I read a lot more about kind of the history of medical and space certification, and boy, there's a lot of history there. So if you're kind of new to the topic, this might be interesting in how we got here and how some of these there's a lot of commonality in why these certifications exist, and knowing your history can tell you a lot about your future. So I have a few slides on that, and then very particular to the space domain, I'm going to spend some time going over a Class D mission, which is the least critical type of mission that I recently discovered for a NASA Goddard project. And again, sharing this information, this public write-up on how they did their certification has been really helpful for us and understanding like what's involved there and how it relates to other types of certification. So again, this open information sharing is quite important. And then the rest of my talk will kind of be my experience and why it can be really expensive to do the certification for more life critical missions and some common gotchas that I've seen. And if you're starting a new project or maybe if you're initially into your development, this might also help you guys out. So I think it's always interesting, especially in the open source community, just to know how large companies are and maybe how many things they have to balance. So PickNik, for those not familiar, we've been in business for about a decade, almost exactly. We have around 30 people, and we're based in Boulder, Colorado, but we also have some remote folks in Europe and North America and really all over. And we work in a lot of industries, not just surgical and space, but pretty much any industry that uses robots or robot arms. We're involved there, and that's where MoveIt comes into play. A lot of these industries have common themes and common tools and common algorithms that they need, and we've packaged those into MoveIt, which was the original Willow Garage project for manipulation, but we're continuing to build out and maintain it. We have a Jazzy release. You can install it from Debian. You can install it from source. I believe we have Docker images as well. But more recently, in the last few years, we found that MoveIt is a useful planning framework. A lot of people use it, but MoveIt by itself is not going to solve everyone's problems. And there's a need for a more reliable basis of ROS, ways to coordinate MoveIt with other frameworks, ways to handle your state logic and transition management. So something we've been working on the last several years at PickNik is MoveIt Pro, which is our commercial solution for companies that are doing motion planning or mobile manipulators, where we still provide all of the expected interfaces to ROS2, but a more solid foundation that we provide some dedicated stress testing and QA testing and some other common tooling that we've found pretty much every company we've worked with in the past that used MoveIt also needed. So in particular, a behavior tree foundation that lets you easily talk to your motion planning skills, which could be MoveIt, which could be your own homespun planning. It could be Nav2, things like that, talking with ML perception frameworks, things like that. So, please visit the website if that's something that you as a company or you as a developer are interested in. And again, having this common foundation where we don't have different versions of behavior trees or different versions of state machines or state charts or Petri nets has really allowed us to apply much more rapidly, develop solutions for different industries, but then also different space applications. So these are all things we've developed in the last 1 to 2 years, working with Space Force, working with NASA, working with space industry partners. Right? This is just space industry. And having this common platform is really important for us to be able to move fast and reuse tools and not have slightly different variations of exactly which ROS distro, exactly which state management framework you're using. So really trying to provide a foundation here so that people can move more quickly. So I'll just say, kind of briefly, some of the missions we've been working on with NASA and the Space Force are satellite servicing. So you can see in the top left, this is a mission where we are working on tools to enable satellite servicing. And there's kind of three key stages to that. There's the initial approach to the spacecraft, which is using propulsion systems. And then the very interesting problem of how you then connect to the spacecraft, because these thrusters require a lot of fuel, and that they're not as precise as we would like. So OSAM-1, a lot of missions, ConOps there is use a robot arm to do that final grappling. So this is our simulator in the top left doing some admittance control work as well as some tracking work. And then in the kind of the top right and the bottom right is more once you're statically connected to the spacecraft you want to service, you can start doing tasks to cut into the robot to access components that could be recycled or perform refueling operations or things like that. And then in the bottom left is some ConOps around the Artemis Lunar Gateway and how we might have a robot system handling a lot of the maintenance so that we don't have to have a lunar space station that's crewed year-round, which is dangerous and also very expensive. So again, lots of like shared foundations, and ROS has done a good job in providing a lot of standard tools, but we've been working on this standard tool chain. But that's all good and well, but how do we actually get this to fly? That's where the Space ROS project comes in, which has a pretty rich history with a lot of industry and government collaborators, and we're very happy to be involved at PickNik. So we're sharing the Space ROS project, but we have a lot of collaborators, and we're really excited that this effort has started to pick up pretty quickly and see a lot of shared desire and vision to move faster towards the goals that we have here of taking these ROS projects and actually being able to fly them. So with that brief history, I wanted to talk a little bit about NPR 7150.2, which is kind of the unified procedural requirements published by NASA. So I'm not going to read through all of this. I believe we're having this recorded, but brief history here. I put some of the big data points, that some of us might be familiar with, but what precipitated the formation of 7150 was the Space Shuttle Challenger disaster. And they found it wasn't that there weren't certification standards before, but NASA decided this was the time to unify it across NASA centers, right? And even more importantly, it's what established the independent verification and validation program to try and address this conflict of interest of delaying missions where we need an external authority to really push back on timelines if there was an unacceptable amount of risk in the project, right? So I have some more reasons why we needed that here. Some non-crewed missions as well. Some pretty famous ones with software designs errors that with tooling today we hope would be trivial to catch, but again, it's your code's only as good as the design behind it. And I also went into a bit of a history on IEC 62304, and again, kind of a little different here in that the formation of this, I think, was more software driven, right? There compared to kind of the more material science and political nature of what the Rogers Commission was established to investigate. There's been some history of also some interesting kind of analogous to some of the lander failures that IEC was tasked with finding ways to prevent that from happening again. And again, pretty similar timelines, right? 2006 and 2004. I forget if I have my slide immediately following this, but it's pretty similar timelines. But yeah, the interesting thing here is for you folks in medical, I'll probably keep saying this multiple times through this, right? But aerospace is a little different in that the ordering of the risk classes is reversed, right? So when I say class A, right, that is the highest risk. Those are human crewed missions or any payload that goes on a human crewed mission that's in the same that's in the same rocket. That's a class A mission. So here are some more examples of maybe some missions that weren't necessarily or weren't on human crewed missions, but were just of critical importance or critical timeline or very expensive programs where risk was not an option. So James Webb is probably the most recent Class A mission of a robotics program, and then you have again kind of the reversed numbering system here, where Category 3 are the lowest risk payload delivery mechanisms, rockets, and then you have risk Category 1s, which might not be, might have no NASA certification. So I have some examples here, but James Webb, think of that, very, very expensive program, very, fundamentally game changing as far as some of the ambitions of that project. But then Class D, you might have more, less risky projects. They might be more satellite imagery projects for scientific gathering missions that aren't going to, risk the safety of the astronauts in the ISS, right? It's a purely information gathering mission. That might be more Class D. And, just to say here, an entire mission is not just Class A or Class D. It's similar to medical devices, right? Where you can have mixed criticality. The most Classic one is the flight control versus the telemetry logging and spaceflight. You could say the same thing for a Da Vinci type system, where it could be the actuator, actual low level command system versus the telemetry system, right? And for people on this call that are relatively new to this domain, right, you would isolate these processes into different cores and use some construct like single producer, single consumer queues to safely share that information between threads or between cores. So I'm going to maybe rant a bit in this talk about dependency specification and dependency management, but this is another reason why it's really important to have clean dependency management, right? If you have some class A or some high risk and some low risk, that's all I'll phrase it in this talk. If you have some high risk and some low risk, that only really saves you, effort with the telemetry logging system, right? Not needing to go through IV and V. If you can isolate the, say that the telemetry logging system doesn't have a direct connection to a more safety critical process. So now I'll talk about a sample class D mission. Again, this is a pretty public documentation, which is fantastic. This is a NASA Goddard mission. And again, this is kind of a information sharing network, which is why it's, it's not endemic to, or it's not critical for, say, the operation of the ISS, right? So this is one of the reasons why I'm under the, why I understand it was classified as low risk, again, class D for space, which means no IV and V, which I'll talk to a little bit later. But I wanted to go through kind of their table. This is their requirements conformity matrix for MPR 7150. And it's a really great table. What I want you to take away from this is for a low risk class D mission, there is so much in this requirements matrix that is fulfilled by using modern tooling, modern DevOps or modern CertOps tooling. And my understanding of IEC 62304 is, a lot of this, you can adopt a framework that you feel, satisfies the suggestions for 62304, particularly for, a low risk medical device, right? So there's a lot of tooling that was used for, let's say, GCN that could be used for these missions, right? And we should continue to share our knowledge on what tooling works, where there's example configuration files, things like that. So basically the things that I've highlighted here in green are artifacts that I believe you basically get for free with modern development practices, right? CI, CD, using static analysis tools, which I'll talk a little bit about later. I think a lot of companies now use at least like linters, which are pretty sparse, fast static analysis tools, but some of the deeper analysis tools, I think those are less well known, and there's some really open source friendly tools that you could be using today. So again, I won't read through this in its entirety. I'll also provide a link to the discourse thread to the GCN website, but the stuff highlighted in green here is basically like, if you're following modern, practices here for a class D mission, a lot of this, you don't need to provide any more documentation because the documentation is already in your process, right? So the GCN mission, used GitHub for most of their processes, and some additional GitHub tooling I only learned about through this. So, it doesn't have to be GitHub. It could be Jira, it could be any number of their tools. I've used half a dozen different tools right now. I think GitHub and GitHub projects, their product management team is doing a fantastic job. So I'm a big fan of all of their tooling. But yeah, basically all these things where you need to, define and document that the acceptance criteria for the software, you can provide that through, through your GitHub Actions workflow or through your issues and your pull requests, right? Showing where such and such bug was documented and how it was fulfilled. That's your GitHub issues and your pull requests and things like that. So there's a few pages of these, so I won't spend too much time on this, but again, some of these dependencies, right? You can set up bots to automatically look for license and copyright, things like that, that you're compliant with that. There's other tools you can use for looking for critical vulnerabilities, right? You need, I don't know, 5 years ago, 10 years ago, probably at some companies today, there's probably someone manually looking for updates to things like that. Whereas you can use things like Dependabot today to automatically alert and make PRs and things like that. I will call out one interesting thing here on Class D is something about cost estimate. I'll be open now. I don't know a ton about that right now. There are standard frameworks, but this is something that stood out to me as far as something on a Class D mission that isn't very well automated with tools today. This is somewhat manual. There's probably a great opportunity out there for, some sort of GitHub or GitLab or some sort of tooling, right, to look at a repo and at least provide some of the inputs to these cost estimate tools, because some of them are sort of like lines of code based or things like that. And then I think it's the last, no, I think there's a couple more, but yeah, again, a lot of these toolings here, dependency management, code reviews, the fact those, exist online in your pull requests, those are your artifacts there. And then the final bit here, some static analysis tools. Again, you need that for Class D, but there's this GitHub project called CodeQL, and another one I'll talk about is SonarQube and SonarCloud. Those are some really great tools that are very easy to set up, and you can configure them with things like Mesra compliance. And then again, the takeaway here basically is like about half of these, as you look at this, are green, meaning that like if you're using these tools, those tools generate artifacts that you can use in this process. And a lot of the others, I think the cost estimate is the main one that flagged to me, are relatively lightweight documentation, which when you look at the GCN website, you'll see that it's a not an extensive, it's a dense but not terribly extensive website. So again, the bulk of this work can be automated with existing tooling. So again, that's low risk aerospace Class D missions. What's it mean as we move into higher risk, where you've got tools inside of your patient, or a system, a payload that'll fly with astronauts, or a system like Artemis that will be maintaining the integrity of a habitat, right? So I will also share a link to basically this NPR 7150 that I've color coded by kind of escalation of Class D to Class A, which I think is a pretty interesting way to visualize it. But basically what I have here, the orange is, higher risk. These are unique to Class A and B missions, right? Where those start becoming mission critical or life critical. And this is where, again, from the Rogers Commission report, this is where IVNV comes into play, where an external entity has to do the validation and verification, which means your requirements for documentation are going to be a lot higher. And you can't just say like, oh, okay, we know where that documentation lives. We know how our GitHub Actions pipeline works, things like that, right? So there's a lot more manual documentation that goes into this today, at least. And the other bit I wanted to talk to here was the requirements mapping. So Class A through C. So starting to get into, a lot more percentage-wise of missions. I think also right now this is a lot more manual documentation, and this is another area. There's existing upcoming tools that the Space ROS project is wanting to integrate. And if anyone's familiar with the medical community's tooling, if there's automated tooling here, I'd love to hear about that. But I think this is probably, again, at least internal to your company, and not talking about if you're doing IVNV, but internal to your company, this is where a lot of the more manual work that could be automated if we develop some tooling here, where there's a lot of gains to be made. And then very briefly on the commercial space side of things, there's commercial space is starting to really take off. No pun intended, but for now, most people are working under NASA contracts, And that means you're, compliant with 7150 if you are using, on the rocket as a NASA payload or NASA crew. So not a lot of change there. The main change is like things like new commercial launch vehicles that are being done independent to NASA. Those are actually subject to some FAA regulations. And this will probably be a pretty interesting year for that, because I think those are not, there's a lot of discussion around if that process is scaling to the sheer number of commercial rocket launches that we're seeing these days, that are not as part of a NASA contract. So yeah, at this point in the talk, I wanted to go through some of the common gotchas I've seen that if you put some additional thought into it ahead of time, you can save yourself a lot of heartache. So these are the things I've seen in the last 5-10 years, probably the top 3 things that if you spend a bit more time pre-planning, you can save yourself a lot of unnecessary manual work. And I've kind of put them in order of least to most effort, very roughly, but something I've seen, pretty much in every project I'm on is rewriting the entire stack in parallel for different development platforms. So you have your MATLAB code base, where maybe R&D is done, and then you have your C++ code base for the production stack. And there's a lot of manual re-implementation, very, very, very painful. And then the second is not establishing a culture of writing code that is going to certify, and waiting until you're pretty far in development to say okay, well now we can start worrying about that, and basically have to, again, rewrite the whole code base or start from scratch. And then the final one, which is, the biggest question, the biggest, hairiest question is, I think, especially in space right now, you prototype on one platform and it's re-implemented by a different team a lot of the time, right? And there's beyond just having to write it twice, there's also a lot of knowledge transfer loss there, which is also slows down the re-implementation effort. So there's a way we can at least reduce how much is being rewritten. Again, there's a lot of gains to be had there. So that rewriting in parallel, I'll add a little more detail here, but pretty much every medical device company I've worked with, typically has at least 3 environments that they work in, right? There's some sort of the actual production system. There's some sort of environment that's testing, simulating, training, all 3 of those, a 3D representation of the robot and how maybe draping or port insertion or things like that work. And then there's another simulator that's more a soft body tissue simulator, right? So there's all 3 of these use the same, all 3 of these require kinematics. And it's very often that none of them use the same kinematics implementations. They'll have 2 or 3 implementations, possibly in 2 or 3 different languages. And again, if you're making changes to how acceleration scaling works, or how jerk limiting works, or how safety boundaries work, you now have to re-implement that 2 or 3 different times. Just, again, pretty frustrating work as an engineer and both as a project manager. So again, just thinking about where you can have common interfaces, design common interfaces, similar for your inputs and things like that, can save you a lot of effort. And then this is my more experimental slide as far as what's the latest and greatest and where there's good example setups. But I mentioned pre-commits becoming pretty standard. It's a pretty light linter. It's meant to run fast, but there are some really great projects up there. So MoveIt, we've used SonarQube Cloud, and GitHub, I learned, has this CodeQL static analysis tool. And there's some really great plugins for those systems. So SonarQube provides some MISRA adjacent checks. They don't necessarily map one-to-one, at least with the current implementation. And then GitHub CodeQL, there's some work being done there. I think specifically with MISRA 2023 and SCI cert. kind of plugins to this CodeQL framework, which both of these are free for open source projects, which is really great. And we use SonarQube internally for MoveIt Pro, and it's also quite affordable. So these are great projects. I've linked a couple of things here, which I'll have to share offline, I think, as far as like what project setup looks like, and it's quite minimal. So there's really no excuse not to be setting this up. It'll make you a better developer. It'll prevent some of these bugs in your code from biting you months or years down the road. So those are great. Those are general purpose tools, great for establishing and building a team culture around those static analysis tools and understanding what design trade-offs that you're making. Do you want to start using dynamic memory allocation? Do you not want to be doing dynamic memory allocation and refactor your stack later down the road? Things like that. But that's just kind of what I know of that's easy to plug in off the shelf today. Some of the goals of the Space ROS project are to, again, have a public workflow that's integrating some additional checkers, right? Some of these will be overlapping. Some of these might all be doing MISRA 14 or something like that, but they might have different flavors of additional checks. And that's why you'll see, just a lot of GitHub action jobs in the Space ROS project as we build it out. So one of the main goals, or one of the nearer term goals with Space ROS is, particularly there's been, again, just like there were disparate certification processes, pre-IV&V, Katherine Johnson Center for the different NASA centers. It's no surprise that they built, their own static analysis tools. Again, different goals. There's never going to be one framework that does everything. So we need things that can plug in different, this one's really good for human spaceflight. This one's really good for satellites. This one's really good for rovers, right? We'll have different frameworks, but working on this aggregated dashboard, which if you've seen any of the Space ROS talks, this will look familiar to you, but Cobra and ICOS, the JPL and AIMS projects for static analysis, getting those running. So we have something in addition to MISRA, in addition to SEI cert, things like that, where you can kind of mix and match and have more guarantees about, this one, in particular, like MISRA's releasing a 2023 spec where it might let you more deterministically enforce use of some of the newer 2023 constructs rather than having to kind of configure that your own. And then a few other tools that are pretty interesting are modified condition decision coverage. So there's this MCDC checker project that we'll be looking to add into the Space ROS code base. And the one I'm personally very excited about, which I alluded to earlier, was this requirements analysis. So there's a project at AIMS called FRET, which is meant for automating some of the formal requirements gathering. And again, if people in the medical community are familiar with an analogous tool, I'm excited to hear about that. But this will help us, more automate what I think is probably one of the most expensive internal processes that are remaining, which is that text translation, a lot of Excel sheets and whatnot of here's this requirement and here's how we fulfill it. If we write good stories and we write good milestones and we write unit tests and we write integration tests, it's all in one place. We just need something to develop those artifacts for us in a more automated fashion, right? So lots of promise there on that project. So here's where I get into my rant about build files. So I've used Bazel and CMake and Ament before, and it's really not fair to put that on just one or two people, right? It has huge implications that I think a lot of people don't understand, and how well you write these build files. So I would say, if you're writing onboarding material for your developers, or you're just entering the market, or you're just transitioning to the medical or space industry, you need to become familiar with these tools, right? And the reason for this is your build files, that's how, dependencies are retrieved. That's how headers are copied over. That's how you can end up copying and building the same header file over and over and over. And it might sound like it's not a big deal initially. It's just some extra build time. You can do something else in the background. But, like I alluded to earlier, as you ramp up your certification process, you are going to be running a lot of tooling in parallel. And if you want to be able to merge your PR in within a couple days of submitting it, you need fast build systems. So that means knowing how build file optimization, how caching builds or Docker images, how that works, right? Because you'll be running different compilers, you'll be running a whole bunch of different, thread sanitizers, address sanitizers, things like that. And then different, other tooling, ICOS, Cobra, some other flavor that probably also does MISRA compliance. And then that's not even getting into integration tests, which, unless you're running faster than real time, that can also take a while. So, and hopefully I've communicated just how important that is. And the reason I'm saying, we don't pay enough attention to that is this is a dependency graph. One of the engineers working on MoveIt Pro generated using some really great built-in ROS tooling. The problem is that the way that some of these projects have their dependencies specified, it works technically, but it is not clean. And if you want to separate, mixed risk or have a very minimal dependency graph that doesn't require you to certify ROS Humble Desktop, for instance, and just certify the packages you want, this becomes pretty important. And I think something else that I've noticed, particularly on ROS discourse is, I think we needed better primers on, what is actually involved in building a package. And there's a lot of conflation around the various ROS tools and the tools under the hood for those ROS tools between, package manager, dependency aggregation, and the actual build system. So I think that's another important thing that as robotics engineers, especially if you're in a safety critical domain, you need to actually understand what's happening here. I know it's yet one more thing to learn, but it's an important thing to learn. And then this is the big hairy question, right? So, how do we avoid prototyping? And then once we feel like, okay, we've got the features we need for this to go to market, now we've got to rewrite it in a more thread safe, memory safe, certifiable, minimal dependency fashion. So there are kind of two options here. Obviously I talked a lot about Space ROS. There's also Apex Grace, where they raised some funding and did a lot of hard work to get a version of ROS that's 26262 ASIL-D, so high risk automotive certification. And this is a pretty old slide. I think this was before it was called Apex Grace. But there's a lot of work that has to be done here. They have a really great post. You can learn a lot from this project. Unfortunately, it's not. It is a commercial project, and you do, as a company, you have a business model that needs to be sustainable. But unfortunately, whatever tools are being used under the hood here are not, super publicly visible. So static analysis tools, things like that, right? And not every project can, necessarily afford to do the same kind of work for maybe a different, certification standard that might require different requirements, different requirements, fulfillment artifacts, or things like that. So that's where Space ROS comes in, right? So Dan already talked a bit about this, but we want not just for Class D, but the high risk Class A missions. That's where we want this project to get us. And again, the benefit there is, or one of the benefits there is greatly reduced mission costs because we're not building multiple versions of a mission. But then also, more accessible, more public, methods of like, this is all the tool chains that we're using. And this is, like that GCN documentation on this is how we, fulfilled the Class D requirements. It'll point to a lot of these tools that exist, but people don't know super well that can automate a lot of the certification process. And then option 2, which short term is, a less ambitious but more realistic take is, start at the leaf of your libraries and start building those out in a way that can talk to both the prototype and the production system, or that can talk to, say, your more R&D experimental simulator, but also your production system or your hardware system, right? So this is a pretty new offering that we're doing at PickNik. So these are some proprietary implementations of controllers for admin control or velocity control, servoing, things like that, where they're built with very minimal dependencies, plain CMake to make that very traceable. And then on top of that, there's a ROS wrapper to talk to all the interfaces that you would expect, all the ROS message types, the MoveIt message types, right, that you would expect, interface with the Mint build system and the ROS ecosystem. So they're very easy to talk to your ROS system and then your production system. This isn't, a new concept. A lot of good libraries out there build, with a minimal set of dependencies and then ROS wrappers around the periphery. I think Davide Vacanti in particular has written a lot of his libraries in that fashion. Behavior Tree CPP, our Data Tamer logging framework, which actually was developed in collaboration with a major medical device company. Those are ones where, again, minimal dependencies and then opt into the ROS wrapper. So that's kind of option 2. And then, as kind of a wrap up before we go into maybe more discussion and Q&A, kind of next steps for Space ROS. Again, like we have these Icon and Cobra tools, which are very powerful. They're open source, right? NASA, JPL built out these projects. They've released them. But one of the big next steps that we want to take with Space ROS is incorporating those into a CI tool chain and documenting those so that other projects can benefit from that. Even if they're not using Space ROS directly, there's a lot you can learn from looking at, Sonar Cloud or CodeQL configuration files. And we want to do something similar for ICOS and Cobra. But even today, like I mentioned, there are some really easy to use, easy to configure static analysis tools. There's no reason people shouldn't be using them. They're really great tools, really great for pointing out where your tech debt lies, code coverage or various metrics of code smell, things like that. And then I guess the other 2 bits here, again, a dependency specification and understanding what a Mint macros do and what, different strategies for how you specify your headers or precompile your headers in CMake. Everyone needs a better understanding of that. And my last bit is, again, it seems like there's some really fast territory to be gained with making certification less expensive and this requirements mapping automation. Like, we have the artifacts there. We just need some way to automatically link them. This is my last slide, but what's next? I talked a lot about CMake, but I think we really need someone at ROSCon Singapore to do a great talk on how you can reduce your build time and have a more accurate dependency graph by kind of parting the curtain on some of the CMake or a Mint magic, and possibly talk about alternative build systems like Meson, perhaps Bazel, things like that. So I think that would be great. I think it'd be good to have more example repositories of these static analysis tools. So I mentioned, MoveIt has Sonar Cloud set up. I would love to find for people that want a couple options, CodeQL with the MISRA 23. I think MISRA 23 is still in beta, but a CodeQL, also configured for a repository. I think those would be really powerful, so people can just copy paste those into their projects. It's not going to fail your PRs unless you want it to, but at least having those tools and being able to poke through the dashboards is, again, really good learning experience. And then what people can be doing just on their own projects and as a community is, let's start cleaning up some of these package XML and CMake list files. And yeah, that's my last slide.
Thank you, Nathan. Gosh, heaps of context. I think well, in the meantime, I'll get people to raise your hands or write some questions. And you're all muted, but if you're on camera, just give Nathan a round of applause, because that's just like an enormous wealth of knowledge for our community to receive from like a space expert. We'll try to filter questions for the time that we have into like clarification and then sort of more philosophical. So if you've got some quick clarifications, I have a quick clarification question of like your rant, I guess, around the build time. If you had a system that it sounds like it's as if it's in the bottleneck of your development, whereas in my mind, I would only imagine these tools are run, say, on nightlies. Like what is it that makes it actually so important enough that it's one of the top 3 points on your like conclusion? I think I missed that link of where it's actually the bottleneck in these developments.
Yeah, I just say, if you, I guess it really comes down to your team size. But if you have more than a handful of people working on the same section of the code base, you're going to end up with quite a PR backlog rate. And you have a couple options there. You can, one that might make it a little bit better is relax some of the rules as far as things need to be based on main when they're merged in. You will occasionally trip over a rake because the algorithm for if things have affected simultaneous 2 PRs that it thinks haven't interacted do interact, you can trip over some rakes there. But at the end of the day, I think it really, if you're spending a lot of time waiting for your queue or, your merge queue, if you're using GitHub's merge queue enterprise, which we've had a great experience with as well, that's probably my sign that like it is worth looking into optimization of your build time.
Okay, so I'll summarize then that it's like from your actual experience, that is where the bottleneck is,
Yes.
at least
Yeah.
where it is in your pipeline in terms of how those tests are being run. I think you've gotten like 90% of where I was hoping you would get in terms of clarifying the goals of Space ROS. Just for like the last 10%, is it the case that Space ROS output is these artifacts that you had in green for the example project? It's really about the artifacts that can then be used to justify using ROS in a product.
So yeah, I guess there's a difference between certifiable and certified. So certified, that's kind of where the legal repercussions lie with the company that has done the certification. And I think right now with the size of the Space ROS project, right, that's not something that's in anywhere in the near term goals of the project. But providing some of those certification artifacts to make it certifiable, yeah, that's something where as we integrate the not just PickNik, right? There's a lot of players in here, but as we integrate some of these additional static analysis tools into the checkers, those can be used as artifacts in your verification process. Not necessarily all of them, right? But some of the things that I alluded to with that Class D case study, some of those would then be able to be linked and say like, oh, I built against Space ROS. Here's my artifact showing at least Space ROS past all these requirements that I've manually mapped out to them.
And I think that was where I saw like the clearest overlap with at least my experience in medical device design, that it's like I also had that moment of seeing somebody's actual submission that they had released publicly, or at least some samples are released publicly, and you go, oh, that's all that's needed to actually justify using a particular open source library. So thank you for giving like insight into, because one of the questions that we wanted to get to is like, actually, how can people make the argument that is like, well, we're talking about class D, or like the entry level risk in space. And I think that's an easier place to start with medical devices as well, which is kind of the message of my ROSCon talk, is like, not every medical robot is a surgical robot, and not every space project is a class is like a rocket with humans going to the International Space Station. Were there any other points, if we were to catch them in one place, that you wanted to make around like how ROS can coexist with space?
Well, I guess one other data point that I guess that people who have been to space ROS talks in the past might be aware of, but MoveIt has flown on the ISS before, but that's another, the risk tolerance there, or the risk management system there was a real-time operating system that was handling the motor commands, right? And I don't know, it'd be great if we had the documentation around this, but part of it was they had done some kinematic limitations to prevent Robonaut, the four-armed crawling robot in ISS. They had done some limitations there with RTOS at a, probably a class A level there, to guarantee it wouldn't exceed certain velocity thresholds or things of that nature, which they had decided remove the risk for the robot to do some, joint space optimal or some unexpected motion and cause damage to the station or to the robot or to the humans. So yeah, it's again sort of mixed criticality and where you can make some intelligent observations there.
So maybe then I'll restate it like, well, it's not necessarily using ROS in like the like I said, in the rocket ships. And then the second thing is that it's not just using ROS everywhere. It's ROS in collaboration with independent supervision. And those can, like, it's the risks that are inherent are mitigated. It's not just like, oh, we just said, we thought about it and then there were no risks. It's like, no, there are risks. And you don't just stop at recognizing that there are risks. You take it one step further and you mitigate them. And depending on the project, like what you said with the velocity monitoring or limits, I think that's how it's done in industrial robotics. It's how it's done in surgical robots that don't use ROS, as well as ones that do. So
yeah, there's a very good case analogy there for surgical robots, I think, where as long as you can, if static action is safe action, then as long as you can prove your controllers, are not going to will fail in a fail-safe way, right? There's some really good isolation of concerns that can be had there, and that was kind of our motivation with the certifiable control modules. Now, as you're working on robots where they're maintaining Artemis, that probably is less acceptable, right? Where inaction could over long periods of time cause unacceptable risk to missions. That's a little different. But in the medical context, where you don't have to fly someone to the moon to restart the robot, right? It's a little different.
Yeah, I love that. It's like in terms of the stepping stones, the one for us to look at as roboticists is like, can this robotic system be transformed into one where emergency stop is a solid backup plan? And if you can morph your system somehow into what you said, like static state is a safe state, that's huge, enormous for risk mitigation. It won't cover everything. If your robot is in an operating theater where the patient is under anesthetic, at least the ones that I've worked on, any time to restart the robot is still a problem, but it's a different type of problem than what people imagine of like, oh, but anyway. Keep the questions coming in. I feel like, anytime that I have to chat to Nathan, I'll I'll certainly use it up. I'm looking for first to grab the clarification questions. So let's simmer those out. And in the meantime, I'll just pop up this is before we lose some people to meetings that are coming up. I'm gonna pop up a feedback poll because I think this will be insightful to our community. Oh, to our community as well as our speaker. But just saying you do have a question in the chat. No, I'll let you unmute. You can now unmute yourself. Go, Martin.
Yeah. Thanks, Nathan, for providing these insights. I was wondering if you could share some more insights on your collaboration with Ascensus Surgical, and whether you were looking at it from an R&D perspective, or whether you're trying to deploy MoveIt in the operating theater there.
So that particular project was not around motion planning. So in that particular one, MoveIt was not a factor. But that one was R&D, but it was, again, kind of designed from the start, knowing they wanted it to interface both against the surgical room system, but then also for training simulators and things like that. So that was one where we're able to take some of those best practices of deciding on the API ahead of time so it could talk to both.
Okay, thanks.
You have another question? I'll read it out for you. Oh, Kyle, you can unmute.
Oh, sure. Yeah. No, I'm just wondering about using robots in the space industry, because in the medical world, you don't have the manufacturers for these general purpose commercial off-the-shelf robots like universal robots and many cobots in the industrial space, but they're not certified. And is there a track to certification in the space industry? Is there, how do you get around or find robots that are purpose-built for space mission?
That's a great question. This is another one where it's a little different between medical and space as far as like testing out and on hardware versus testing out on certifiable domain-specific hardware, and that any sort of hardware tests in space involve paying for a launch vehicle, and that's usually such a high barrier to entry cost-wise that paying for an arm that's been purpose-built for space is usually, incrementally not that expensive. So I think that's, something different where like in the medical, you'd prototype a lot, with a non-surgical grade arm, and your production system would use, a surgical grade hardware arm. In space, I don't know that I know of anyone that's tried to say like replace the grease in a COTS arm and fly it, just because the expense of getting that up into whatever orbit you're talking about is already pretty expensive.
Thanks.
I have a question for you. If someone is working in medical robotics and hoping to leverage the work that Space ROS does, how important is it to stick to Humble as a ROS distro?
Yeah, I'll actually on that previous question, I'm reading the text version of that chat. Is that it? For medical robots, it's hard to find manufacturers that are certified. If you have a list of manufacturers that you've used, please go to our PickNik ROS2 hardware vendor page. There's a form to submit. I think that would be a great addition to that page, or particularly, maybe like IP rating, and specifically if it's medical grade or something like that. So that's a pretty great page resource we started recently. And if you'd like to see something that helps you guys out more there, please submit a form.
Restating to check I understood is that there's already work you have in progress, momentum to collect ROS or like MoveIt compatible hardware vendors, and then we can add the context if they also have medical certification to avoid the people in this room duplicating each other's work when looking for ROS compatible hardware.
Yes. So I just put that link in the chat.
Thanks.
Please share that around. We've found that this webpage has been particularly effective in having the vendors come to us, telling us they want to be on this page, rather than what PickNik and other people have done historically, which is us trying to go to the vendors and be like, please tell us information, and not having a ton of success, to be honest. So, whatever you guys can do to share that you're paying attention to that webpage puts more pressure on the vendors to get on that webpage and provide us the information that you guys need. So yeah, your question was around ROS Humble.
Yeah, and then we can extend it to just more. It's that connection of like, how can we leverage each other's work as community within the community and across the communities, and that was an example of it. But
that's a big question. I'd say right now with MoveIt's available on all of the distros, right? But I also talked about MoveIt Pro, which is our commercial platform where we do a very extensive testing. And for those, we've locked down a version of the ROS snapshot. And, we might bump particular source checkouts as we submit PRs to upstream repositories. But I think that the biggest conversation there, honestly, is giving feedback to OSRA about how we want resources that companies like PickNik, who are sponsors of the project, the balance between, say, new feature development and support for LTS that are still in distro, right? So I'd say one thing that's a challenge for us is we want to provide that solid foundation, but ROS releases very quickly, and there's a lot of packages and a lot of we try to be hardware agnostic, so that's a lot of packages from a lot of vendors, we need a lot of resources to keep up with the pace of release, which is why we're working on a particular public version of Humble. But then it comes to when we run into big fixes that are breaking, would be breaking if they would require a lot of effort, I guess, to backport to Humble without breaking API. And there are a lot of fixes on Jazzy, for instance, that you'd have to make a big jump to pull in that fix, because it would be expensive for it to be backported to Humble in a non-API breaking way. And I think that's something that we need to figure out if that's where we need more attention and more of OSRA's focus to live, is really supporting those LTS, so that companies that are in safety critical spaces or even just production cases, right, don't go and privately fork Humble, for instance, and make backport manually a change that is breaking from Jazzy to Humble, because I think that's one reason why we see a lot of private forks, right?
and since we're on the topic, I'll ask you so that you can clarify. You guys are using a fork or not?
We're not using a fork. We do use source forks, but those are pointing to PRs that we're waiting to get merged upstream, right? So all of our ROS dependencies, RCL-CPP, right? We use public versions of that, but right now it's a particular version of Humble.
Yeah, I can certainly relate to that in that we're using Humble at the moment, in part because of I'm looking to get an answer to that question for our development of how much will we regret if we switch to Jazzy when some great artifacts are included with Humble that would be a treat for our submission. And low-hanging fruit, I had a pleasant experience lately where, okay, like I nearly didn't bother to ask something to be backported because, oh, you know, I've been one of those maintainers and it's not always your top priority. But that's one of the things where like automation does make the lives of maintainers easier, which then makes actually staying on like the older LTS just a more livable experience. But there's a lot of low-hanging fruit, and then if you backport all of it, it becomes like obviously the gap between the distros becomes smaller. And part of why I was reluctant to ask in the first place is because you go, well, they'll just say switch to Jazzy if you want the new features. But it is actually, I feel like we represent a large amount, or maybe a small quantity of the community, but still large impact of the community. Hey, we're pinned for good reasons. I have in my mind, though, that what you said is like to look at what Space ROS have done as a starting point. You know, in theory, the processes that you have run to make the artifacts for Humble, like how much effort is it to do them again for new distros? Obviously, it depends, but it's enough that you're not considering, or perhaps you have considered bumping Space ROS to Jazzy.
Yeah, so I guess, you know, I was speaking more to MoveIt Pro than Space ROS, but there is ongoing work that I believe Brian Kempa's leading around moving Space ROS purely to Jazzy. And, you know, this is something where there's like quarterly releases, which at least would enable more batched checking. But the idea eventually, right, is every commit that goes in would get checked rather than us having to pull in large swaths of not upstream of you know, the ROS2 core libraries, right? So there's still, like, I think there's still, I don't want to speak for the whole project, but there's still certainly some strategy to be put in there. But the idea is like, if all of the static analysis is automated, then assuming that the changes you're pulling in were developed against those, which is where the crux is, then the artifacts are free, right? As long as you can automate running it, then your artifacts are effectively free. But then that's kind of this like mixed standard as far as like, well, there's still development going on in you know, ROS2. How do we pull those in nicely in Space ROS?
Maybe then I'll segue. I know we don't have unlimited access to your time. I've clicked a share button. Do you see anything in the survey? Did anything come up on your screen? Can you see the poll results?
I think I closed it.
Even if you can't see them, there's the message that I'm hearing from the audience in their responses is just that you have managed to express like the value of what you were calling certops and like the importance of these tools being integrated into the workflow. That's at least the theme that I'm getting from these responses, but also the similarity. Someone explicitly said like they were surprised by the similarity between space and medical, which is I don't know. I want to be surprised as well, but I come to realize that any safety critical domain starts to sound like the same thing. You swap one standard in for another, but they're looking for you to justify your use of whatever software it is that you're using. Kyle, sorry, I thought you had your hand up from before. Please ask a question about MISRA while we're on the topic of safety standards.
Okay, yes. I think this one, I think you made a point about it, like choosing whether you want to have dynamic memory allocation versus static. And that is often a barrier to adopting or engaging with open source software, especially in robotics. I know that, you know, anytime I've been adhering to, in the compliance matrix for MISRA, like if you choose to have that static memory requirement, it really limits you, and you have to really build things from the ground up. And I think it's harder for companies, private companies, to put that kind of investment into that code development and then have it out there for the world. Have you found any packages or code, or do you use any code base that doesn't have any dynamic memory allocation whatsoever as part of its standards?
I'm sure there's some good examples out there publicly. I guess the one, this isn't quite exact, but Data Tamer is a logging, more like a numerical logging system that we developed in the past. That's not quite, it's not quite like avoiding use of STL string. I don't know that I know of a good public version of that, which goes to your point, right? These can be expensive to spin up, but once you're familiar with the patterns, I think the main challenge there is like, some of the ways we make ROS agnostic don't work very well in that paradigm. But writing individual libraries where you're using, fixed length and pre-allocated vectors and SPSC queues, that was one of my, first medical projects, was working with that type of framework. And I found it, it's, once you have the framework in place, it's not the worst to develop against. But then the use of plugins pretty verbosely and ROS starts to become a pretty big issue there. I see Oracle's KDL is a good example of a zero memory allocation. So that'd be good to check out.
And maybe that can be another session just to get that overlap between like industrial robotics, or any humanoid. They're also dealing with pretty tight control loops, and they manage to use ROS in the process through tools like Oracle's. It's I think this is one step towards just breaking this myth that like ROS can only be used in research projects. I think that myth, which is what not just Space ROS, but also, like you said, like MoveIt Pro is really helping to do. Because when I speak to people who from outside of the ROS community, I've heard one of the myths that I am working to kind of combat is that ROS will just auto update itself. And you just touched on it very briefly, but like how you manage a fleet of however many, or you've got so many customers who are using MoveIt Pro, and do you personally have a concern that their installations will just somehow auto update to a new when a sync is made?
The tools exist to prevent that from happening. Either pinning a particular version, a particular snapshot, but this kind of goes back to, we need to understand, people say like, oh, this is ROS is doing this or ROS is doing that. It's like, well, is it actually ROS doing that? Is it AMINT doing that? Or is it APT doing that, right? And this, like, people need to spend some more time understanding what ROS is actually doing versus things underneath the hood. So I'll also put a link in the chat here to my colleague at PickNik, David Sobek. This is a really great discussion about some of those like interactions between ROSDEP and APT and how it pulls packages. And this isn't about auto updating, but it is adjacent to that topic as far as, when we went to build Space ROS, we wanted to not pin a snapshot. We wanted to build everything from source deterministically. And we found a lot of gotchas where people didn't understand how package XML or AMINT path prefix or things like that interacted with each other and interacted with the build system. So it's a pretty long read, but it's, I think, pretty interesting. And there's some links to some PRs that are fixing some issues we identified.
You resend it. Maybe you were talking to someone individually. I didn't get it.
Oh, yeah, I sent that to Shashank. Thank
You're a
you.
lucky caller. Thank you. And there's a bunch of people waiting in the wings. I'm just checking nobody needs. I'll stop talking for 10 seconds in case that's someone else is looking to ask a question. Otherwise, while we have people's attention still, what are the places that you would like to see more community involvement? I think you mentioned one or two, but if you've been thinking about ways that really like medical community can learn from the space ROS community, or just ways that we can be involved more proactively than just coming and listening to you.
Yeah, I mean, I think trying to find a step that's before before that, but yeah, I think that talk that's like demystifying ROSTEP and AMENT and really like separation of concerns and what's responsible for what, just a general but better public discourse about that, and I think just more interest in that. So I think there's also yeah, probably some great discussions on the AMENT GitHub org that it'd be good to for at least one person at each company to be very familiar with that.
Yeah, and perhaps even for me, I've had some insight, at least listening to you, of like, oh, I thought that other people were aware of these things. And so I do think that it can be challenging. That's been my experience in the ROS Medical Community. People think that they don't have anything to share. And it's like, no, even if like now the people in this group are relative experts in what you've just spoken about compared to other people in the medical ROS community. There's like so much opportunity for information to flow downstream because of all the like information void that exists. And so perhaps kicking up the dust somehow, raising just visibility in ourselves that like there is information that other people don't have that we have, I think can facilitate that sort of like knowledge transfer. But the knowledge isn't getting transferred, in my opinion, because people don't think that they're sitting on any knowledge that anyone else is of interest.
Yes. Who's giving the next talk?
I got 4 people on my screen here, so let's see. Well then, any further context for MoveIt Pro and the features that are coming down your pipeline in the context of medical before we wrap up?
Yeah, I think the main one is just like that certify. I don't think I linked the page. Let's make sure I send it to the group chat. But yeah, that's a pretty exciting development that, we're kind of attacking this problem from both ends with Space ROS and the NASA funding that we've received and are applying for to continue doing what we can to speed up the goals of that project, right? But then something that we as a 30-person company feel like we can have a more immediate impact on is attacking it from the other end, which is the control modules. And again, I think we developed these originally for Space Force and NASA, but like we've talked about already, I think there's a lot of opportunity there with the particular like risk profile of surgical systems, right? Where this could also have a lot of great impact where, if again, that kind of like, is a static robot a safe robot? I think there's a lot more you can decide what fail safe means in a medical context and not a space context there.
Thanks. Well, this is from what I understand, the the certifiable control modules in PickNik sort of fit into the quadrant of like you're using, or not quadrant, but the approach to using ROS in a medical device, that it's like you phase it out at a particular, or you stop using those wrappers, strip those wrappers out, but it's minimal change that you need to make to your software as you move towards certification.
Correct. Yeah, so you can still prototype on, say, like, a non-medical grade KUKA, and your production system's using a medical KUKA. Well, you know it's going to behave the same way, aside from whatever performance improvements you might get from a RTOS middleware or something like that.
Yeah, and I'll just say that, like, it sounds, for people who are wondering, I get asked a lot by researchers, like, what's the path to turning this into a product? And I think that's, for today, one of the tried and tested methods is like to phase ROS out. I'm pioneering or trying like a different prong, which is to leave it in, but in a lower risk setting. And then I know of people who are working on a third prong, which is they'll, I guess there's one where it's like you keep it in different, just for particular activities, sim, and I imagine the certifiable modules are amenable to that. And then there's the other approach where like use a version of ROS that lets it stay in. I know some people who are working on that. You can get in touch with me, I guess, if you want me to put you in touch with them, and maybe we'll have them as like another session so that we can see these different, more of a smorgasbord for people to see which approach will apply to their own project, because we're all sort of advancing the state of the art ourselves, whether or not we intend to, just by being, we're working on really cutting edge novel things, this room. So it, if you want to also have a shout out or speak at a session, I'm sure that there are many more people doing accidentally innovative things just by virtue of there being a lot of unexplored territory in this space. So we would love to learn from you, like we've done from Nathan today. And for those who are left with us, please thank Nathan again with me, sharing that expertise with us, so that as a community we can, like I said, work towards bringing more medical devices to market sooner and stop reinventing each other's wheels. So
Thank you for hosting.
enough.